Hello everyone, my name is C. Jogendra. I am from Gayatri Vidya Parishad College of Engineering, currently pursuing my BTech in the branch of ECE. Today I am going to discuss about the ALU with System Verilog testbench. Coming to the contents of this presentation, I am going to first explain the design, how will be the System Verilog testbench block diagram, and different components of the System Verilog testbench and top level testbench which will be used to run all these components. Coming to the design part, the main ports of the design are input ports which are A, B, enable and command, and one output out. These input ports are used to send data to the design, and various arithmetical and logical operations will be calculated according to the command we choose in the input. With that, it will give an output for us. Firstly, I have declared the port direction as input for AB, enable and command, and output for the output port. And I have taken a temporary register Y so that I can store the data, intermediate data in that register. I have declared parameters for every operation like addition, subtraction, so that I can directly use the word add, sub and mul like that everyone. And I have used a always block, and in that always block the sensitivity list I have given the command AB. If any of these three changes in the input side, then this always block will be executed. And in that always block I have used the case statement, and the input will be command to the case statement. The expression will be command. If we send 4 zeros, that means it will be a add command, so that y will be a plus b. Like that I have written the all arithmetical and logical operators. And at the end of the design, I have checking for the enable. If enable is 1, then the out will be the data which is present in the temporary register Y, or else it will be in the high impedance state Z. This is my entire ALU design. And coming to the block diagram of System Verilog testbench, this is the main block diagram. First we will generate the data using a generator. In this generator we will randomize the data and send the data to the driver. We use transaction packet to send the data from generator to driver using a mailbox, and the driver will send the data to the interface using a virtual interface connection, and the interface will drive the design under test. The design under test will take the inputs and generate some outputs according to the input. Those inputs will be monitored from the class called monitor. From here we will take data from the design and check whether the data is correct or wrong. And from the design, from the monitor we send the data to the scoreboard, and in the scoreboard there will be a reference model. We also take data from generator. We also send data from generator to design under test. We take that output from monitor. From monitor, the data will be sent to scoreboard. The scoreboard will perform a reference model operation on the input data and check whether the reference output and output from DUT are same or not. All these components are present within the environment. The environment will run all these components. We will run the environment from external file called test. This is the external layer test. This test will be run from the top level test bin. Coming to my transaction class or packet class, first I have declared all the inputs and outputs, and as I am randomizing the inputs, I used the keyword rand to tell that these can be randomized and sent to the design under test. And I have also written a display function so that I can know which class is running or which inputs and outputs are currently running in the device. I used a function called display. And coming to the generator class, first I have created a handle for the transaction class so that I have used it as a packet, and I can also use it for displaying the current data. And I have created a mailbox gen to drive. which can be used to send data from generator to driver, so that the generator can run the design under test. New function I have in new function I am taking a mailbox as input to the function, and giving that mailbox to the current mailbox within the class, that is gen2 drive. And I have written a task called main, in which I am creating a new object for the transaction class that will allocate a memory. This trans will be the handle of the transaction class, and this new will create a memory for this handle. And here I am randomizing the trans. Like previously we wrote that rand for a, b, enable and command, so that a, b, enable and command will be randomized by using this function. I am calling the display function in the generator, so that I am calling the display function in the transaction class by sending an string called generator, so that it will print a line and a name called we have. As we send the generator will be printed, and all the data will be printed according to the randomization, and all the data will be put into a mailbox called gen2 drive. After generator, we need to look into the interface also, so that we can virtualize the interface. The interface, we will just need to write all the ports according to our requirement of the design under test. I am calling my interface as intf, so that it can be used anywhere in the program. This is my driver class. In driver class, first I am virtualizing the interface. As I write the interface as intf, I am virtualizing by using the virtual keyword virtual intf. It is my interface name, and VAF will be the virtualized interface name. And I am also creating a mailbox gen2 drive within this class. Now to run the driver class, I have to newly create a mailbox and a virtual interface. For that, I need a virtual interface and mailbox to get me as an input. I'm taking the virtual interface and mailbox to this function, and declaring as mailbox and virtual interface in this class. This dot virtual interface is equal to virtual interface coming from the outside, which will be which will be used when calling this function, and same as the mailbox. In this also I am writing a task called main, in which I am driving the design under test using the data I have previously generated. I have also created a handle for the transaction class called trans. Into the gen2 drive mailbox, I am getting the data in the trans packet which we have sent from the generator class. We are taking the data and putting it into the packet called trans, so that we can get the data. Trans.a means a variable which is randomized. These four variables will be driven to the virtual interface. By that we will connect to the design under test directly. The data will be driven to design, actual design we are discussed earlier. And we are also just printing the status. We are also printing the current status of the outputs, so that we can keep a look on it. I am calling the transaction loss display is equal to driver. Display, I am passing the driver string, so that it can print that. And coming to the monitor class, we have to observe the data data output from the design. So we have to take data, so we need a interface. Now we are again using a virtual interface, same as previous one, VAF. And now we are creating a new mailbox, monitor to scoreboard mailbox. By using this, we can take data from the DUT and send it to the scoreboard. So in this also I have written a new function which requires a virtual interface and mailbox to be sent to run this function. And I am initializing both the virtual interface and mailbox with the mailbox and virtual interface present within the class, so that I can use them in the function or task I am using. Here also I have written a main task so that I can get the data from the interface. First I am creating a handle for the transaction class called trans, and also for that handle I am creating a object by using the new function so that memory will be allocated for the trans. In trans.a I am by using the virtual interface I am getting the a value from the DUT. So the a value will be present in vf.a. It will be sent to the trans.a. Like that I have taken all the values, all the input output ports data from the virtual interface, and pasted it, and send it to the transaction packet and placed it in the transaction object. And I am putting the entire transaction object in monitor to scoreboard mailbox by using monitor to scoreboard dot put function, and again calling the display function in the transaction class so that I can view the data coming from the DUT by using the dot display function. Coming to my scoreboard, here also I have creating a handle for transaction and mailbox called monitor to scoreboard, which will get the data from monitor and deliver it to the scoreboard. Here I am building a reference model for checking whether the inputs and whether the outputs are correct from DUT or not. First, I have parameterized all the functions add, subtract, multiply, and divide by using the parameter keyword. And as design, I have used add, sub, all the functions same as in the design. But here I am passing the inputs which are from the packets, not from the generator. uh, I am getting the inputs and generating the output within this scoreboard class so that I can use it as a reference model, and this is called as a reference model. According to the inputs it will calculate a output and it will be stored in the out function. It will be stored in y. If trans.out is equal to y, then the test will be passed. As our output will be stored in the reference model, output will be stored in y, we will compare it with the DUT output, which is stored in the trans.out. We are getting this trans.out from the mailbox monitor to scoreboard. As we use a monitor to scoreboard dot get function for getting the details from monitor, we will compare both the outputs, and if both are same we will print as test pass, or else we will take as test fail. I am concatenating by using the concatenation operation. I concatenated the scoreboard and pass or fail string both and send to the display function in the transaction class so that it will display it as a scoreboard, and with attached to that it will display pass or fail. Coming to the environment, we will use all of the classes within the environment. We will first include the files which we have written earlier, and we will create a class called environment. In this environment we will create a handle for generator, driver, monitor, and scoreboard, which will be used for running the tasks, which we have written the new tasks and main tasks. In every class we will run those tasks from the environment. First I have created the handle gen for generator, driv for driver, mon for monitor, and scb for scoreboard. And I am also declaring two mailboxes m1 and m2, which one of those is generator to driver and other one is monitor to scoreboard. Here also I am writing a new function so that I can call this new function from the test file test.sv, which can be called from the top level test bench. In this new function, I am giving the input for this function as a virtual interface, and declaring this virtual interface as the virtual interface declared within the class, and creating objects for the mailbox so that a memory will be allocated for the mailbox. As we return new functions in generator, driver, monitor, and scoreboard, we are passing some inputs to the function and running those new functions in this environment. And I have written a task called test, which will run the main tasks which we written earlier in the monitor driver and monitor driver, test bench and scoreboard. And I have named this task as test. To run this task test, I have used another task run, so that at the end of running this task, I can write $finish so that the simulation will be stopped. So we have to run two tasks in our test file. That is the new task present in the environment, which we have to send input a virtual interface and a task run. We also have to run the task run. This is our test.sv file. In this, which I am including the environment.sv file and writing a program. This program will be run from the top level test bench. This program name is test, and the input for this program is a virtual interface. And I am creating a handle for the environment as env, and by using a initial begin block, I am running the new task by sending a virtual interface. And as discussed earlier, I am running this task run by using env.run command. And coming to the top level test bench, I am taking the interface and test bench files which we have written earlier. I have declared a module TB underscore top. It denotes as top test bench, top level test bench. Our interface name, we know that our interface name is intf. I am creating a handle for that, I underscore intf, and to the program I am sending the interface name by using a denotation t1. And also I am instantiating the ALU design by using the name DUT, ALU DUT, and by name based instantiation I have instantiated every input and output port of the device. This is my top level test bench. These are the output logs I got from the design. I will run the design once a bit. First we will run generator so that it will randomly generate inputs, and output will be unknown as we are not sending, we are only generating randomized inputs. And by these values will be sent to driver, and the driver will send these values to the design under test. And by using monitor we get values which are sent to DUT, and also as design calculates the output, we can also get the output. As our scoreboard has a reference model, the reference model generated the output 38608, and also our design also generated the same output so that it printed as test pass. And this is the waveform which we got by running the program. And now I will run this is my actual program. I using EDA playground to run my program. And here I am declared my design input output post parameters and always block and case module. So these are all the test bench files. These are System Verilog test bench files. This is our top level test bench. Here we are running the test. This test will be in the tester.sv. This is the test program, and these environment new and environment dot run will be present within the environment. This is the environment new function, and this is the test run function. Test run function, we run the task test. In test run task we run the task test. In test tasks we are running the generator driver monitor scoreboard main tasks. This is our transaction packet as earlier discussed. This is our interface. This is our generator and generator. This will be the new function, and this is the main function. In driver also we have a new main as follows for the monitor, new and main scoreboard. This will be the reference model. Till this line it is a reference model. In y we will get the output, and here we are comparing it with the trans.out actual output we are getting from DUT. so that we can declare the test pass or fail, and concatenating with the string called test scoreboard and sending it to the transaction. I will run that. We can see the outputs in the log. This is the generator output. Generated a random variables for the enable command A and B, and using the driver we are sending it to the DUT. From monitor we got the output as 38608. Also scoreboard also generated the same value, so the test will be passed. We have got a small problem. We can rerun the program. We will get the waveforms also. We got the waveforms. 1 minute. We will remove all this and we will take only inputs. We will take the DUT values. We need command. We need enable. We need out. We need to add signals. DUT. We need to add A and B. Here this is A, FE and B is 98. As our command is 2, it will indicate multiplication, so both will be multiplied and our output will be 96D0, 96D0. This will be a hexadecimal. We can change the radix to the binary. These are the outputs we are getting from graphs. These are same as these outputs when we convert into decimal. If you want to run multiple times, we want to run the test multiple times, we can use a repeat in this test and run it multiple times. Thank you.